Hello everyone, welcome to lesson 11 in math. It's integers. Today we're going to learn how to add, subtract, multiply, and divide integers using the rules. And we're also going to learn how to plot integers on a quadrant graph. So part 1A is adding integers. There are many methods, or there are a couple of methods to use when adding and even subtracting integers. Some of them are the chip model and the number line, but these can be time consuming when working with bigger integers. I know when we're first learning about integers, like in younger grades, you may be taught with the chip model or the number line, but as you get older and you work with integers kind of on a daily basis, especially in algebra, it's going to be difficult to have to make the chip model or use the number line every single time. So that's why we use rules when adding, multiplying, subtracting, or dividing integers, and it makes everything much easier. So for adding integers, these are the rules here. And the more you practice, the easier it's going to get. At first, it might be like you're bombarded with a bunch of rules and you're like, oh, which one do I use when? But just refer to the rules anytime and keep practicing, and it's going to stick to your head and you're going to be able to do these within like 2 seconds. So the first couple of things here to note is when you have a positive addend, and addend, we should know these terminology and stuff by now. Remember, addend is the two numbers you're adding, and then the sum is the final answer to an addition equation. So positive addend and another positive addend will always give a positive sum. When you have two negative addends, two negative numbers, then they're going to give a negative sum. But say if you have a mixed one, so positive addend plus a negative addend, or vice versa, it's going to depend. And I wanted to make this more clear. So what it is here, if you have a bigger positive addend and a smaller negative addend, and we're going to take a closer look at these later, you're going to have a positive sum. And if you have a smaller positive addend and a bigger negative addend, it's going to be a negative sum. So here's an example. And I gave the example with the mixed addends just so because positive plus positive is always positive and negative plus negative is always negative, so that's easy. So technically here you have negative 3 plus 5. Pretend the 2 is not here. Pretend we don't know that yet. So what I did here is based off of these rules. Well, I look at it and I'm like, okay, so I have a smaller, or I have a bigger positive addend and a smaller negative addend. So that's going to give me a positive sum. So in order to do that, here's the step for this. It's to subtract normally. So you're going to take 5 and subtract 3, which is 2. And you're going to attach the bigger integer sign to the final answer of sum. So the bigger integer in this case was 5, positive 5. We don't really put the positive sign, but you could always attach the addition sign to it. But it's positive 5, so it's a positive number. We're going to put the positive sign on the 2. And like I said, you don't need to put the positive sign on the 2. It still indicates that it's a positive number. So the final answer is 2. But let's switch those integers around. Say you have negative 5 plus 3. And let's say this answer is not here. Well, I look at this and I basically have a bigger negative addend and a smaller positive addend. So I'm still going to do the same thing. I'm going to pretend like the 5 is a positive. So ignore the negative sign at this point. You're going to subtract normally. 5 minus 3 is 2. And then you're going to attach the bigger integer sign to the final sum. The bigger integer was 5. It was a negative, so we're going to put a negative sign like in front of the 2. And then our final answer is negative 2. And the reason I have some asterisks here is because the step only applies to positive and negative rule. Like I said, I chose to do this rule just so you can see it better because these two ones are pretty straightforward. So here are some practice questions for you. I recommend you do them. It really helps, and I'll put the answers in the description box. Part 1B is subtracting integers. So with subtracting integers, we do the same change rule. What this means is you have the sign of the first integer, which stays the same. You're going to change the subtraction sign to addition, and then you're going to change the sign of the second integer. So it's kind of wordy here, but I'm going to go through a couple of examples so you can see what I mean. When you have a positive minus a positive, it depends. Negative minus negative depends, kind of like the same thing as here, like you attach the bigger integer sign. Positive minus negative is always positive, and a positive or negative minus a positive is a negative. So let's take a look at this example, 5 minus 20. When we're applying the same change rule, we keep the first 5, So the sign of the first integer stays the same. We keep the 5 as a positive 5. We're going to change the subtraction sign to addition. So here we change it to addition. And then you're going to change the sign of the second integer to the opposite, obviously. So it was technically positive 20. It's going to change into negative 20. So now we get a new kind of expression, and it's 5 plus negative 20. In order to do this, we're just going to pretend we're going to go back to subtracting. So that's why sometimes subtracting gets a little confusing, because you're doing like subtracting and then adding, and like it's like what's going on. But yeah, we do have an adding here. So what do you do when you have an adding? Well, referring back to our steps here, you subtract normally. So we're going to subtract 20 with 5. Again, pretend the negative sign is not there. So 20 minus 5 is 15, and you attach the bigger integer sign to the final answer. In this case, the bigger integer sign was negative. So you're going to put a negative 15 there, and that's your final answer. 6 minus 4, this is pretty straightforward. It's 2. So how we said a positive integer minus a positive integer depends. It's because in this case we had a bigger positive integer first and then a smaller one. So 6 minus 4 is 2. If it was 4 minus 6, then that would have been negative 2, because we had a smaller integer, positive integer first, and then a bigger positive integer. And so moving on is negative 8 minus negative 12. So applying the same change rule, you would keep the first integer the same thing, so negative 8. You're going to change the subtraction sign to positive, and the negative 12 becomes the opposite, which is positive 12. So now we're going to do 12 minus 8 and attach the bigger integer sign, which is positive, so it's positive 4. Then you have 25 minus negative 17. Again, applying this rule, same first integer, this operation changes to addition, and negative 17 becomes positive 17. So 25 minus 17 is 8, and because the bigger integer is negative, you're going to make it into negative 8. 6 minus negative 8. So again, same change rule. So you would do 6 plus positive 8, which is 14. And finally, here we have like a negative integer minus a positive integer. So negative 3 minus 10. Negative 3 stays the same. Subtraction changes to addition. Negative 10 or positive 10 becomes negative 10. In this case, when we're doing a negative plus a negative, if we go back to our addition, negative plus negative is always going to give us a negative sum. So going down here, 10 plus 3 is 13, and we just attach the negative sign. Okay? And again, that goes back to this idea how negative integer minus a positive integer is a negative difference. So here are some practice questions as well, and you can take advantage of these. The answers will be in the description box. Part 2.8 is multiplying integers. So the rule for multiplying and dividing, personally, I find is much easier than adding or subtracting, just because it's just pretty straightforward. But overall, they're all easy. Again, practice makes perfection. So positive integer times a positive integer is going to be positive. A negative times a negative is also going to be positive. And if you have a positive integer times a negative integer, or a negative integer times positive integer, it's going to be negative. So here are some examples. 3 times 6. These are both positive, and it's going to be positive 18. Negative 8 times negative 12. Well, first we do, for example, 8 times 12 is 96. And we look at this, well, they're both negative, so it has to be a positive integer, and then therefore it's a positive. If we have negative 6 times 20, again, it doesn't matter if it's positive times negative or negative times positive. It's the exact same thing for multiplication. So it's going to still be negative, so it's going to be negative 120. And here's some practice questions, because multiplying is pretty straightforward. That's all just the rules, and I provided some examples, and now you can do the practice. Part 2b is dividing integers. The rules are similar to that of multiplying integers. When you have a positive dividend divided by a positive divisor, it's going to give a positive quotient. A negative dividend divided by a negative divisor is going to give a positive quotient as well. But when you have a positive divided by a negative, it's going to give a negative quotient. So some examples are here. 90 divided by 10, they're both positive. It has to give a positive answer, and the answer is 9. Negative 10 divided by negative 5 has to give a positive quotient. The answer is positive 2. And negative 12 divided by 4 is going to give us a negative quotient, so it's negative 3. And again, here are some practice questions for you. So part 3 is a quadrant graph, as I mentioned in the beginning of the video. Quadrant graphs are just as another way to help us memorize on a graph which axis is positive, which one is negative, and stuff like that. So that's why I've provided this, because we still technically use integers as you move on, and as I teach more lessons moving on to algebra, integers will be everywhere we use, or in any equation or stuff like that. So that's why it's good to practice also knowing the quadrant graph, because as you move on and say you do stuff like functions or advanced functions, you will be using the graph a lot. So taking a look at the graph, it has 4 segments or 4 spots. The top right is always going to be positive, positive. So the x-axis is positive, and so is the y-axis. And then to the left of that, so the top left, is going to be a negative, positive. And it's important to know that it's first negative and then positive for the top left. Because you always read it from x-axis to y-axis. So the x-axis is going to be negative on the left side, and the y-axis at the top is going to be positive. Then moving down to the bottom left-hand corner is both negative. So the x and the y-axis are negative, and then the final segment, or the bottom right-hand corner, would be positive and negative, because the x-axis is positive while the y-axis at the bottom is negative. And then just in the center is the origin, and I just labeled it. So that would mean 0, 0, and it's neither positive nor negative. It's just 0, 0. And here I have an example with graphing. I put the mouse with this feature so you can see the graph or where I'm pointing to. So say you have for A 2 and negative 1. So you go to 2 on the x-axis and negative 1 on the y, and you plot it over there. Then you have for B 3, 3. So you go to 3 on the x-axis and 3 on the y-axis, and it's going to B is going to be over there. Then C is negative 3, 0. So that means that we have a x-intercept or x-axis, but we do not have a y value. So that means that negative 3 is right here, and there's no y. Then you have 0 and negative 3, so that means that there is no x value. There's only a y value or y-intercept. So on negative 3 for y, you're going to go down and you're going to plot D over there. Then for E, it's negative 1 and 2. You are going to go to negative 1 on the x-axis and positive 2 on the y. So E is going to go over there. F is 4, 2. So you're going to go to 4 on the x and 2 on the y. So F would be plotted over there. And the final one, G, is negative 2 and negative 2. So negative 2 on the x and negative 2 on the y. And G would be plotted over there. And here I have a practice question for you if you choose to do so, and I'll put the answer to this in the description box as well. So this was our lesson for today. Hopefully it made sense. We're going to be using integers a lot as we move on. And yeah, so thanks so much for watching this video, and see you in the next one.